We will start with the stoichiometry of chemical reaction. What is stoichiometry? Stoichiometry means the quantitative relationship among the reactant and the product in a reaction. And stoichiometric coefficient is a chemical equation can be interpreted as the number of moles of each substances. For here in equation N2 plus 3H2 giving rise to 2NH3, the stoichiometric coefficient in the equation indicates 1 mole of N2 reacts with 3 molecules of H2 or 3 moles of your H2 and give rise to 2 molecules of ammonia or 2 moles of ammonia. This information can be taken in the form of number of molecule as 6.022 into 10 to the power 23 molecules react with 3 into 6.022 into 10 to the power 23 molecules of H2 to give 2 into 6.022 into 10 to the power 23 molecules of ammonia. And similarly, if I want to interrupt it in the form of mass of the substance, it will be 28 gram of nitrogen reacts with 6 grams of your hydrogen to give 34 grams of ammonia. This relation between the quantitative analysis of the reactant and product is known as stoichiometric coefficients or stoichiometric chemistry. To carry out the stoichiometric calculation, first of all, we have to write the chemical equation for the reaction. Then we have to balance that equation. And then we have to establish relationship between various stoichiometric coefficient in the equation. These relations may be between mole to mole relation, mass to mass, mass volume, or volume to volume relation. Then we have to write the actual quantities of the substance given in the equation and then calculate the result by the unitary method. For example, how many moles of nitrogen are needed to produce 8.2 moles of ammonia by the reaction with hydrogen? So here nitrogen and hydrogen are reacting to produce ammonia. So first of all, I have written the equation here, N2 plus H2 give rise to NH3. Then I have balanced the equation by putting 3 over here in front of H2 and 2 in front of ammonia. The question has asked me the relation between nitrogen, moles of nitrogen and moles of hydrogen. So from the equation, we came to know that 2 moles of ammonia is produced by 1 mole of N2. So 8.2 moles of NH3 will be produced by 4.1 mole of NH2 by using the unitary method. And I have given you another question. Chlorine is prepared by treating manganese dioxide with aqueous hydrochloric acid by the equation MnO2 plus HCl give rise to MnCl2 plus H2O plus Cl2. On balancing it, we get the equation as I have written here. How many grams of HCl reacts with 5.0 gram of manganese dioxide? So now the relationship will be made between MnO2 plus and HCl because it has been asked in the equation. So 1 mole of MnO2 is forming 4 mole of HCl. If I correlate this information in the terms of gram, it will be 87 gram of MnO2 reacts with 146 gram of HCl. So 5 gram of MnO2 is reacting with 8.39 gram of HCl. Now there comes the limiting reactant. The reactant which is completely consumed when the reaction comes to completion is called limiting reagent, and the other reactant which present even after the completion of the reaction means it is in greater amount and therefore it is known as excess of reagent or excess agent. For example, A plus B 2 give rise to AB2. Identify the limiting reagent in the following reaction mixture for 300 atoms of A reacting with 200 molecules of B. Out of these A and B, which one is in lesser amount, which one is in limiting reagent? So we know that one atom of A should react with one molecule of B. Therefore, 300 atoms of A should react with 300 molecules of B. As a result, we have only 200 molecules of B in given. So this B becomes the limiting reagent which will be completely utilized during a chemical reaction. And when the chemical reaction is completed, the 100 molecules of A remains or left behind without any reaction. So A becomes excess of reagent. Again here 2.5 mole of A reacts with 5 mole of B. According to the equation, 1 mole of A reacts with 1 mole of B2. So 2.5 mole of A should react with 2.5 mole of B2. And here I am having only 2.5 moles of A will react with 2.5 moles of B. So another 2.5 will left as an excess unreacted of the B. Therefore, B becomes excess and A becomes the limiting reagent. In this question, 50 kg of N2 and 10 kg of H2 are mixed to produce ammonia. Now we have to calculate the amount of ammonia formed and the limiting reagent. So first of all, we will go for the limiting reagent because the formation of ammonia will be calculated only by the limiting reagent. So this is the equation and the balance. I have balanced it. From the equation, the information is that 1 mole of N2 is reacting with 3 mole of H2. That means 28 gram of N2 is reacting with 6 gram of H2. 28 into 10 to the power 3 kg and 2. I have converted this gram into kg is reacting with 6 into 10 to the power 3 kg of H2. So 50 kg of N2 should be react with 10.71 kg of H2. Means for the reaction of 50 kg of N2, 10.71 kg of H2 is required. But in the question, only 10 kg of H2 is present. So H2 will become the limiting agent. And with this limiting agent, we are forming the relation with the ammonia because only the limiting reagent will give me the formation of the product. The other one will remain unreacted. So here 3 moles of H2 is reacting with ammonia to give 2 mole of NH3. 6 gram of H2 is going to give me 34 gram of NH3. And similarly, 10 kg of H2 will give me 56.6 grams kg of NH3. In this way, we have calculated the formation, how much NH3 has been formed. The next one is the reaction in solution. The amount of solute present in a given quantity of a solvent or solution is expressed in the term of concentration. The concentration of the solution can be expressed as mass percentage. It is the mass of the component per 100 gram of the solution, and we can find the masses of the different component with the formula WA upon WA plus WB, which is the total mass of the solution into 100. Volume percentage, it is the volume of the component per 100 gram of the volume of the solution. Again, VA upon VA plus VB into 100. ppm is the part per million. It is the part of the component per million part of the solution. Mean out of million, how much part of that component is present is known as ppm. Next one is your molarity. It is the number of moles of the solute dissolved per liter of the solution. So molarity is denoted by capital M and its unit is your mole per liter. The formula is number of moles of the solute upon volume of the solution in liters. Molarity, it is the number of moles of the solute dissolved per 1000 gram of the solvent or per kg of the solvent. It is denoted by small m and its unit is mole per kg. The formula is number of moles of the solute upon mass of the solvent in grams into 1000 or simply here in kg. It's from the mole fraction. It is the ratio of the number of moles of one component to the total number of moles present in the solution. It is denoted by X. So the mole component of the mole fraction for the component A will be Na upon Na plus Nb, where Na is the number of moles of component A and Na plus Nb is the number of moles of the total solution. Xb will be Nb upon Na plus Nb and Xa plus Xb is equal to 1. As mole fraction is a ratio, it does not have any units. Here, molarity depends upon the temperature because the volume changes with the temperature.